Today, what we're going to do is we're going to use the tools that we have when it comes to right triangles to solve right triangles. We did this in geometry a little bit where we would find all the sides and all the angles for a right triangle. Now, depending on what you're given, you can use Pythagorean Theorem, you can use Sohcahtoa, you can use inverse Sohcahtoa functions, or you can subtract angles from 180. So not all of these problems are going to be done the exact same way. It really depends on what information you have. And I tend to try to use the methods that require the least amount of work. So if we look at our stuff down here, what I like to do is use trig ratios if possible, or Pythagorean theorem to find missing sides. But if I already have two angles in a triangle, then I know what the third one is, so I won't use the inverse trig ratios for that case. So look at example 1, letter A. We have two angles. This box is 90, this is 56. So if I do 180 minus 90 minus 56, that's going to give me my missing angle of 34 degrees. So I know angle A is 34 degrees. Now to find the missing side, since I only have one side, I can't do Pythagorean theorem. So I'm going to use Sohcahtoa. So let's label our sides. This is our hypotenuse. Now the opposite and adjacent, again, depend on what angle you're talking about. Well, we have both angles, so which angle do we want to talk about? I always like to use the angle that's given to us because I know that's correct. What if we calculated this angle wrong and now we're using sine, cosine, and tangent of that incorrect angle? So 56 is the angle. This is going to be the opposite side, which makes this the adjacent. So we're going to write out Sohcahtoa. And let's find the opposite side first. I have the adjacent, so I'm going to underline the A's. I'm trying to figure out the opposite, so I'm going to underline the O's. So that's going to be tangent. So this is going to be the tangent of 56 degrees equals O for opposite, which we don't know, so X, over the adjacent, which is 13. Now we want to get X by itself, and we're always going to multiply both sides by the denominator, not the number, not the numerical number that we see in the fraction, by whatever's in the denominator. 13 is in the denominator, so we're going to multiply both sides by that. So this side, we're going to type that into the calculator. We want to make sure our calculator is in degree mode. So mode, mine's in radians, so I'm going to go and change it to degrees. So now I'm going to do 13 times the tangent of 56, and I get 19.27. So side B is 19.27. Now with side C, you could do two things. Now that we have two sides, we could use the Pythagorean theorem, or we could use Sohcahtoa again. I'm going to use Sohcahtoa because I don't want to use this number in case it is wrong. So we're going to write out Sohcahtoa again. And I'm going to underline my adjacent side again because that's what I'm given. It's 13. And I'm going to underline my H's for hypotenuse. So I am trying to find the cosine. All right, I'm going to use cosine. So cosine of 56 degrees equals 13 over x. I'm not going to multiply both sides by 13 this time. I'm going to multiply both sides by the denominator, which is x. That goes away. So x times the cosine of 56 equals 13. And then we will divide both sides by the cosine of 56. So x equals 13 divided by cosine of 56. And I get 23.25. So side C is 23.25. Now I want to point out the difference between angle C and side C. Notice that side C is a lowercase c and angle C is uppercase. Angle A is a lowercase a, angle A is an uppercase a, and then side A is a lowercase a. And they are across from each other. Like side A doesn't touch angle A. That's how we work with triangles. So we solve this triangle. We have side A, B, and C because A was given to us, and we have angle A, B, and C because angle C is 90 degrees. Now, letter B over here, we have two sides. If we have two sides, we can use Pythagorean Theorem to find this third. So this is A, B, C. So 13 squared plus B squared equals 19 squared. So let's solve that. So 169 plus B squared equals, I think that's going to be 381. Sorry, 361. Then we'll subtract 169 from both sides. And we get B squared equals 192. And then we can square root both sides. Now, square root of 192 is a decimal. So we want to simplify this radical. So I'm going to do 192 divided by 4. I get 48. I'll do it over here. So I'm going to do 192, divided by 16. I get 12. Okay, so 192. Can I do 64? All right, 64 and 3. So B equals the square root of 64 times the square root of 3. The square root of 64 is 8, so B equals 8 times the square root of 3. So we have the three sides now. To get one of the angles, we're going to have to use Sohcahtoa and use the inverse functions because that's what we use to find an angle. I'm going to look at angle A right here. This is the one that I want to find. So Sohcahtoa. C is the hypotenuse because it's across from the box. 13 is the opposite side because it doesn't touch angle A. And then side B is the adjacent. So I know the opposite. Underline my O's. I know the hypotenuse. Now you could say, yes, you know the adjacent because we did figure that out, but I was given the opposite and hypotenuse, so I'm going to use those. So I'm going to do the inverse sine of 13 over 19. Inverse sine of 13 over 19. And I get 43.17. Well, if angle A, the measure of angle A is 43.17 degrees, I can now do 180 minus 90 minus 43.17. And that's going to give me 56.83. So then angle B, measure of angle B is 56.83 degrees. So we've solved the triangle. We already know what sides A and C are. We also calculated what side B is. It is 8 times square root of 3. And we know that angle A is 43.17 degrees, angle B is 56.83 degrees, and angle C is 90 degrees. So we finished this problem. using some of our other methods. We use Pythagorean Theorem at first. Okay. So I want you to try this one. Pause the video and try it. You are given one angle and one side, so this is going to be more like this example right here. So go ahead, pause the video. Once you're done, unpause it so we can compare our answers. All right, so you can see the answers that I got. Go ahead and check them. You can see the work. This was a nice problem because since we knew the hypotenuse, we never had to divide both sides by the trig functions, or we never had to multiply both sides by x and do that extra step like we did in this part right here. It was nice and easy that we always got to multiply both sides by the denominator, which was 22. So let's look at the next page, please. While you're standing at this point in the Grand Canyon, you measure an angle of 90 degrees between Powell Point and Woodforest Point, as shown. You then walk to Powell Point and measure an angle of 76 degrees. The distance between is about 2 miles. Okay, so we have the picture here. How wide is the Grand Canyon between Yavapai Point and Woodforest Point? So we're trying to find x right here. So let's write out Sohcahtoa. The hypotenuse, I'll use a different color to draw on here. Hypotenuse, because it's across from the box. This is the opposite side, and this is the adjacent. So we need to figure out the opposite, but we know the adjacent, so it's tangent. The tangent of 76 degrees is equal to O, opposite, over the adjacent, 2. So multiply both sides by the denominator. In this case, it's 2. So then in the calculator, I'm going to do 2 times the tangent of 76, and we get 8.02. So x equals 8.02 miles. So word problems are not that terrible when it comes to Sohcahtoa. Now down here, we're going to talk about what's called angle of depression and elevation. Again, we did this in geometry, so this should be a little bit of a review. Notice that the angle of elevation is when you look up at something. So if you're on the ground looking up at something, that's called an angle of elevation. Angle of depression is when you are on top looking down and your line of sight is going this way. But notice the angle of depression is formed with the horizontal. The angle of depression is not this angle on the inside here, because normally we would say that this is a triangle. This is not the angle of depression. Your angle of depression is out here. But because of parallel lines and transversal, these two angles are congruent. So the angle of elevation up to the top of something is the same as the angle of depression from that something looking down at you. So let's say there was like a bird up here, or let's say an animal. And your angle of elevation, you're down here, the angle of elevation up to the animal is the same as the angle of depression from the animal down to you. So these two angles are congruent. So we're going to use that and look at this problem below. Step 1 is to always draw a picture. So you're measuring the height of your school building. You stand 25 feet from the base of the school. So let's see, here's our building. We're trying to figure that out. We're standing 25 feet. The angle of elevation from the point on the ground to the top of the school is 62 degrees. So this angle right here is 62 degrees. And here is a right angle. So this is the hypotenuse, the opposite, and then the adjacent. So we'll write out Sohcahtoa again. We're trying to figure out the opposite. It's x. We know the adjacent. It's 25. So we're going to use tangent again. So the tangent of 62 degrees equals O for opposite, x over 25. So then we'll multiply both sides by 25. So 25 times the tangent of 62 is 47.018 or 47.02 feet. So being able to label your triangles is super important in getting these done. All right, I'm going to let you guys try this last one. So pause the video, try it, and once you're done, unpause it, and we can make sure you got the right answer. All right, so here's a picture that I drew, and then the math, trigonometry, and you see that I got x equals 34.29 feet. So this lesson was a bit of a review from geometry last year, so it was nothing new. We just needed to go back and kind of just remember how we did things. So thanks for watching the video. Make sure to like it and subscribe.